Hi, my name is Jonathan, and I just love to create things. Out of my art, my film, and even the occasional backyard chemical synthesis, I must say I love tinkering with electronics and programming the most. Today, I'm super excited to show you some of my favorite projects. In ninth grade, I was inspired by Michael Reeves to make a device that shoots me in real life every time I got shot in a video game, just because I thought it would be absolutely hilarious. I wrote a Python program that takes a screenshot of my health bar and uploads them onto Baidu's number recognition API to get an integer value. The code then checks for false positives, and if my health has decreased, it sends a serialized signal to the hardware via Bluetooth. The hardware consists of an Arduino, and it receives signals from my computer via this Bluetooth card, before opening this relay to fire the airsoft gun. I then made a YouTube video, and of course tested the device on myself. So, did I get any better at the video game? I don't think so, but I sure did get a lot better at pain tolerance and coding. For my next project, I was commissioned by my school's athletic trainer to make a device for safer deadlifting. So, I first interviewed the athletic trainers to understand how velocity data can be used to tell if an athlete needs a break to prevent back injuries. For the prototype, I first used an accelerometer to integrate for velocity, but that proved to be less accurate than just using a sonar sensor to derive for velocity. So I wrote some Arduino code that uses sonar sensors to display the max velocity per rep, so athletic trainers can see if the patient is slowing down. During the testing, I figured out that the user experience wasn't so great, so I combined my passion for art by rendering some product designs in Blender after interviewing a gym bro about what a consumer might want. I'm currently working on implementing the case designs and using a Wi-Fi card to wirelessly transmit data. And the last project I want to share is a self-stabilizing ambulance stretcher. The project first features a robot that uses a custom pathfinding algorithm, OpenCV, and a Raspberry Pi to simulate how an ambulance might drive. To detect centripetal and sudden accelerations, I attach a gyroscope onto a gyro frame. The pitch and roll data is then sent to the Raspberry Pi to control two servo arms, which then counteracts the pitch and roll for the stretcher. I decided to use servo arms after testing a bunch of other ideas in SolidWorks. Of course, to make the idea practical, I surveyed paramedics on Reddit before designing ideas on how the mechanism can be attached onto pre-existing ambulance stretchers in Blender. Other than my projects, I also love sharing my passion, whether it's through teaching robotics or Python programming. In the future, I hope to continue my love for creating to make greater and bigger impacts. Thanks for watching.